So the next data structure that we want to learn about is map. Okay, a map is like a hash table, and it has two implementations: hash map and tree map. Tree map is implemented internally through balanced binary search trees. So the operation, whatever operation we will do, would be log n complexity. Hash map is more of like array implementation, array based implementation. So this would be like a constant time put and get. Okay, but there is advantage of tree map that if you want to store the keys in sorted order, then you can use tree map. In hash map, there is no guarantee on the order of the keys. Okay, so I'm going to explain the map functions through taking just going through hash map, but whatever function we'll discuss here would apply to tree map as well. Here I have created this string, and this is not, I mean, you don't have to understand how this syntax works, but like what I'm trying to do is I'm trying to create a map m, which is a new hash map of string and integer. Okay, so this is our key, type of our key, and this is the type of our value. Okay, as you can see, so for put, so put is the method that is used to add an entry to the map. Put has two arguments, key and a value. So I'm kind of I'm passing, first argument is key and second one is value. So I'm using this put 5 times to kind of add 5 entries to our map. Let's see how we can traverse this. So again, we would use the for each loop, which is the simplest one. So, and this is one of the ways to traverse a hash map. What I would do is, I would say, I want to traverse, give me a set of entries. Okay, so I would say m.entry set, and this would give me a set of entries. So set of entries means each type is of type entry. Okay, so I would write entry, and entry, so entry is a type which represents the values in the map, the key and the values. Okay, so this one is one entry, this one is second entry, this one is another entry. Okay, so when we do m.entry set, this gives me a set of all of these entries. Okay, so you can think of entry as something, a class which has two values, a key and a value. Okay, so what we can do is entry of type, and what would be the type of the entry? Same, right? The key would be of type string and the value would be of type integer, right? So I would write like this, and let's give it e. Okay, and I have to import it. Okay, so map.entry. Okay, and then what I would do is I want to print key and value both. Okay, so let's do it like this. E dot get key, and then space, or let's use this, anything will work, value. So that's how you access key and a value. Let's try to run it. So you see, this traversed the entire map and printed the key and the values. So anytime you have to traverse a map, look for a key. Looking for a key is different, but like if you have to traverse your map, you can use this syntax. Okay, all right, let's move on to the next thing, which is insertion. Okay, how can I insert in this map? So simple, I have to use put, and again here we are doing like 5 insertions, so it's similar, right? So let's say I want to add AA with value of 100. Okay, so this would add another value, and again if I'm printing, it would show me the new key, which is AA100. Okay, all right, next there is one more method. So you would find this situation very common, that I want to first check if a key is present or not. So what happens if I do like this, m.put, and then I say AA, and then I say 200. Okay, and then let's say I want to print the value for AA in our key. So So to retrieve the value for a key, we have to use get and pass in the key. Okay, so let's not print the entire queue, entire map for now. Let's just, so what I have done is I have put a key AA100, and then in the next statement I have just put the same key again. So what would happen, it would update the value corresponding to that key. Okay, it doesn't throw any exception or any error, it would just update. You would encounter situations where you want to check if a key is present or not. If it is not present, I want to add. If it is present, maybe I want to skip. Okay, so we can do that with if else. We can say like if m dot contains, there's some method like this, if m dot contains key, and then I would say AA, then I would say then do nothing. And if does not contain, so I added a negation which is like the reverse condition, m does not contain key, then m dot put, okay, this thing. Okay, so now this should not update the key, right? Let's print it and see if it works. Okay, so here you see we just got 100, which means it didn't update it. But there is a direct method to do it. Okay, instead of using this if and using this method contains key, we can simply say m dot put if absent, okay, AA, and then 200. Okay, so what this method does is it would check first if AA is present or not. If there is no key AA, then it would add AA and 200 entry to the map, otherwise it won't update it. Okay, so let's see now. So as you can see, we are still getting 100. Okay, let's use AAA now and see. So there is no key with AAA in our original map. Okay, so we added a key with AA but nothing with AAA, so they should be adding a new key. Okay, so let's see now. So this added a new key with value 200. So that is about put if absent method. So it's a very useful method, you should keep it handy. Now about retrieval. So you see, like we are using get to fetch the value corresponding to a key. What if I want to say that if the key is not present, then default to some value, and if the key is present, then return me the value corresponding to that key. How can I do that? Okay, so in this case, for example, let's say I am doing BB. So what would happen? It would return null because BB is, any key with BB is not present here. Okay, but let's say I want to have a default value of 0. Okay, so what I can do is get or default BB and then any value, let's say 0. Okay, when I do that, now it returns 0. So this method, like it first checks if the key BB is present or not. If it is present, then it would return me the value corresponding to BB. If it is not, then it would use this default value. So for example, if I just do B now, so key with value B is present here in our map with value 2. So this should be returning 2. So as you can see, we got 2. Contains check, if a key is present or not, we saw using the if, using the contains key. Similar to contains key, there is a contains value method as well. Okay, so it checks whether a value is present or not, any entry with that particular value is present or not in the map. So if m dot contains value, and then let's say I pass 100, then I want to say that 100 is present. If not, I want to say 100 is not present. 100 is not present. Okay, let's run it and see. So 100 is present because we have this key AA with value 100, but let's say I'm doing 1000, which is not present inside our map. So okay, so we have to update this as well. Sorry for the confusion. So 1000 is not present. Okay, so that's how this contains value to check whether the map contains any entry with this particular value. Deleting a key, this simple method m dot remove. Okay, what it would do, let's say I do 100. So we have to pass the key and it would remove that entry from the map. So there would be no key with double A, okay, because we just removed it. Okay, so that's how you remove an entry from a map. Size of a map is very simple. We just have to use m.size and this would give me the number of entries. Okay, let's remove this part. Okay, let's see how many entries do we have. So 6, right? 5 here, 5 puts here, and then 1 put here. So there are 6 entries. And again, we have empty checks, right? If map is empty or not. So same thing. If m dot is empty, if the map is empty, then do this. If not, then do this. Do whatever. So you can use this to put any logic based on if the map is empty or not. So let's talk about two more methods, compute if absent and compute if present. So consider this scenario where I want to do some computation on the value if the key is present or not. So how we can do this? One way is to use if else condition, right? If for example, let's consider that I want to add a value of 100 if our key is present. Okay, so let's take this key. I'm just using a variable and I'm saying let's use this key as a. Okay, and I'm saying that contains key, then do what? Add a value of 100. Okay, so what I would do is m.put, I want to update the key. Okay, and whatever value is present with a, I want to add 100 to it. Okay, so what I would say, I would m.put and then key, and I would say m.get key and then plus 100, right? And after this, let's verify. Okay, let's see if this works. 200, right? So initially we had 100 corresponding to a, but we did some computation, and since the key was present, so it succeeded. Okay, what if I want to kind of write it concisely? So for that we have a method, it's called compute if present. So what I would do is I would use it, compute if present, I would use the key, and then it uses a function. Okay, so this is a short way to write a function. Okay, so this function, you can think of it like that, that this function accepts a key and a value, and then it would work on the value. Okay, so we have to pass these arguments. So we can use any parameter names, but let's use k and v. Okay, and then what I'm saying is v plus 100. Okay, so this is a short way to do the same thing. Okay, let's see. So it again printed 200. Okay, so don't get confused by this part. So think of it like compute if present wants to compute if the key is present. So the first argument is key. Okay, now what computation it wants to do? So computation essentially means some function. We have to pass some kind of function, and this is a way to pass functions in Java. Okay, this is called lambda expression. We would have a separate video about lambda expression later, but for now just assume that this function accepts two arguments and then a function body. That's what a function contains, right? Arguments and function body. So these two arguments are key and the values. Okay, and Java understands that we are passing key and value, so we don't need to specify the type here. Okay, but you can write it like string and int v, but I mean we can totally skip it. So just k and v, and then this arrow, and then after the arrow, this is the syntax of lambda function. After the arrow, you just have to write your body of what you want to do. Okay, so if we have like multiple statements, what we can do is we can use curly braces. Okay, and if we are using it, we have to use return statement. So I think this would do the same thing. Okay, but since we had like just a single statement inside our function body, which is just to add 100 to the function to the value, what we can do is we can go back to the shorthand, which is just saying v plus 100. Okay, so that's how this lambda function is working. We'll talk about it more in later examples. Okay, so similar to compute if present, we have a similar method called compute if absent, which does the computation when the key is not present. And how it works is compute if absent, and I would pass in a key, and then it takes a function which it would apply, and then kind of update it in the map, update this key into the map. Okay, so what we can do for an example is, let's say I say key, and then I would say k dot length. Let's say I want to store the length of each key. So my map is like kind of stores the length of each key. So what I can do is like this means that if the key is absent from the map, then store this k dot length into the map. Okay, so and let's use this key AAA, okay, which is not present in our map at this moment. So let's see what happens. So now when I'm doing m.getKey, so it prints 3, which is the length of the key. Okay, so we can use any other computation if you want. Important thing to notice again, the arguments, right? This is again a function. This was a different kind of function. This is a different kind of function. Okay, compute if present, it accepted since the key and value were present. So this function works when both key and value are present, right? So it accepts two arguments, k and v, the key and the value, and then it does some computation. Okay, we can do any kind of computation here again. If the key is absent, then we are passing. So what it does is it checks if the key is present or not. If not, then it would add this entry to the map. So to add the entry, it needs key and a value. Okay, and the value depends on like it has to be any. It could be any computation, right? So it just says that okay, add a value of like the length to the map. Okay, if I want to skip it, this is like kind of a shorthand for this statement. Like if I have to do it like using if else, m dot contains key, then I would say key, then m dot put, okay, key, and then key dot length. Okay, so this we can do it in just one line, compute if absent. So it's similar to this one. We'll see more examples of like the lambda functions going ahead. I would also make a video totally on the lambda function, because these are like really cool ways to write like concise code, right? So I would create a video for that as well. That is it for the hash maps. Okay, so let's learn about sets. Okay, a set is a data structure which contains unique values. So if we try to add multiple values with same quantity, like it would just it would add only one copy of that. So what do I mean by that is I'll demonstrate by taking a set of integers. Okay, integer. So here I'm using a hash set. In Java we have two implementations for a set. One is HashSet and another one is TreeSet. So HashSet and TreeSet. So TreeSet is basically implemented internally through a balanced binary search tree. So again, its operations would be of like log n. So if I want to, for example, I want to check if an element belongs to a set or not. So that operation would take log n in case of TreeSet, and in case of HashSet, that would be a constant time. Okay, but again, same as maps, TreeSet would keep the keys in a sorted order. Okay, so let's see now the methods, how let's try to add few elements to the set. So I would do set dot add, let's say 3, and then let me just copy. Okay, so 4, 6, and then 2. Okay, So I have added few elements to the set. So 3 is added. I'm trying to add 3 multiple times, okay? But if we, so this is how you traverse a set. I mean, you can just use a for each loop, okay? Since it's a integer set, so we would just do like this, okay? And then we would do this, and then n, okay? And let's print everything in one line. So as you can see, there is only one copy of 3 in the set, right? How do we get the size of set? So you can just do something like this, set dot size. Okay. It's very simple. So 4, okay? And same for empty check also, like we have the same method is empty. Okay. Let's try to run it. So false, set is not empty because obviously it contains elements. Okay, so we saw remove. Okay, let's see how we can check if a particular element belongs to the set or not. Okay, so for that we have this contains method. So and it returns true and false boolean value. So set dot contains, and then I would pass, let's say I'm passing 3, whether 3 belongs to my set or not. How can I see this? So as you can see here, it's coming out true. Okay, let's say I'm checking for 9 now, which is not present in the set, so it would give me false. Okay, all right, so we covered traversal, size, contains, remove. Oh, we didn't cover remove. Okay, so let's say this gave me true, and now what I would do is I would use remove. So to remove any element from a set, we use remove method. Very simple. And then we pass the value that we want to remove. Okay, and then let's try to print this one again. Okay, so first I'm trying to print if set contains 3, and then I'm trying to remove 3, and then I'm trying to print check again whether the set contains 3 or not. So let's run it. So first it printed true because 3 was in the set, and then I removed it, and then later for the second print statement it printed false. So that's how you do a contains check, and that's how you remove an element from a set. Okay, add we saw. Let's see how we can add array elements to a set. So we encounter this situation frequently in Leetcode. So the situation is like this. We have our elements in, let's say, an integer array or any array, and we want to basically add all those elements to a set. Okay, so how can we do this? So let's see. Let's first create an array. Okay, so int arr equals new int. Let's say I'm creating size 5. Let's try to initialize. Okay, let me try to initialize it in a loop only. Okay, so for int I equals 0, I less than 5 plus I, arr of I equals I. So I'm just initializing with I. Okay, now how can I add all these elements to a set? Right, so how can we do this? So one way to do it could be through loops using the methods that we just saw. Okay, so what I would do is I would just iterate for int n in arr. I would iterate through every element of the array, and I would say, okay, we don't have a set, so we have to create a set first. So set of integer. Okay, new hash set. Okay, what we can do is set dot add n. Okay, so this would add the elements to a set. If we want to see, then we can just print it out. Okay, let's print it on the same line. Okay, yeah, so 0 1 2 3 4 all the elements are in the set. Okay, now what you can do is how can I add, like I want to avoid this loop and I want to add all the elements from this array into a set. So how to do that? So let's see the syntax for that. and then we'll explain how that is working. Okay, so I would use a method called add all, and then I would do something like this. Okay, let's first see if I just say arr set.addAll arr. This won't work, right? So if I try to run this, there is an error, right? So it says incompatible types. Int array cannot be converted to java.util.collection extends java.lang.integer. So what this error actually means is that it is expecting some collection object, okay, but what we are giving it, we are giving it integer array, which is a primitive integer array. Okay, so it won't work. If you want to fix this, there are two ways. First way is to just convert this into a collection integer, okay, integer object. So as I have said previously, is like every primitive data type has a wrapper, right? So I can use that. Okay, and then everything should work. Okay, still not working. So because integer, we are still passing integer type. Okay, so we have to convert this integer type into this list. Okay, so arrays dot as list, and then I would say arr, and that would work. Okay, but if I try to do the same thing using primitive type, that won't work. Okay, so we can see that. Okay, so you see we are getting this error, and it's the same error, incompatible types. So so that is one way to solve it, like use the wrapper object. Or how can you convert it? Like let's say I don't want to use the wrapper, like I don't want to create another array with wrapper object. Let's say this is our argument in a function, and I don't want to create an extra loop to kind of convert this into an integer wrapper. Okay, so what can I do? So this is how the syntax works. So I would say arrays.stream, and I would pass arr, and then I would say boxed. Okay, I would explain like what each of these means, and then I would do collectors.toList. Okay, and now this would work. Okay, so this is working. So let's try to understand how this is working. Okay, so but I won't go into much detail in this video. Maybe in some other video where I would cover lambdas and streams, I would explain this statement. But for now, arrays.stream is just like, it's kind of it's kind of, you can think of it like it's just kind of sending like each element, it's kind of inputting it into, like creating a stream from this array, and then boxed. So this is important. What is boxed doing? Boxed is basically converting each element of arr, which is a primitive int type, to a boxed, means a wrapper integer object, which means this object. Okay, it is converting into this object. Okay, and then we are doing nothing, we are then just collecting each of those. Okay, so we are then just collecting each of those boxed objects into, and this is the way to convert it into like to a list. Okay, so collectors.toList, and then I'm using this set.addAll method, so that's why it is working. Okay, we can also collect them as a set. Okay, so we can directly do this, and we don't need to like do set.addAll. So what I would do is, see, I would directly say, will this work? Yeah. Okay. Okay, so it's directly converting it into a set, and then that is my set. So let me try to run it. So as you can see, I got 0 1 2 3 4. Okay, so keep this in mind, like for now you don't need to go into the details of like what stream means and everything, what box means, but this is if you encounter any such scenario where you want to convert an integer type into a list or a set, you can use the same syntax. So here I am converting into set, but if you want to, we just saw how we can convert it into a list. Okay, let's also talk a little bit about tree sets. Okay, because there are few methods which are specific to tree sets. So okay, let me also talk about how we are creating this, like this statement, set of integer equals new hash set. Okay, so set is a common type to both hash set and a tree set. Okay, so but there are some methods which are very very specific to tree sets. Okay, like comparison of two keys. Okay, because the whole idea of tree set is to sort, like keep the keys in sorted order. So let's try to create a tree set and see how it works differently. Okay, so let me change it to tree set. Okay, okay, all right, let me just add each array element into this tree set, and so it would work similarly, right? But what different method does it have? So let's see what specific methods TreeSet have. Okay, so one of these those methods is ceiling. Okay, uh, so what does ceiling do? Like ceiling would find a key which is equal to or greater than the given parameter that is passed. Okay, so let's just do it. Set dot ceiling, and then let's say I'm doing 4. Okay, so what it would return? Let me try to print this one, whatever it returns. Okay, so since our set contains 4, so it would return 4. So as you can see, it returned 4. But let me just make it more clear. Let's not print the set contents now. So as you can see, it is returning 4. Okay, but let's create a custom set here. Okay, let me do it like this. Okay, so let me add few elements to the set dot add. I added 9. Okay, and then I'm adding 29, and then let's say 14. Okay, so let me now just try to find the ceiling of 7. So let's first see the set contents. So let's see both of those. Okay, so first I am trying in this statement, I'm just trying to print whatever the set contents are, and then in this statement I'm trying to see the ceiling of 7. Okay, let's see. So as you can see, the set contains 0 1 2 3 4 9 4 14 and 29, but the ceiling of 7, ceiling returns the, if the set contains 7, it would return 7, otherwise it would return just the immediate larger value to that. Okay, similar to ceiling we have floor. Okay, and it works similarly. It returns, if 7 is present in the set, it would return 7, otherwise it would return a value which is just smaller than 7. So in this case it would be 4. So as you can see, it returned 4. Okay, okay, what else? So there are few other methods. Since there is a notion of ordering now in the keys, right? So we can do something like this: poll first, because now we know what is the first key. Okay, so in the sorted order, what is the first key? In our case it would be 0, right? So if I do poll first, it would just, let me remove all of this. Let me remove this thing. Yeah, so what I'm doing here is I'm just using this method poll first, so it would remove the smallest key. Okay, so let's see now, run it. So 0 1 2, you can see this was our original content. Okay, and then when I did poll first, so it removed the first element from the set. Okay, similar to poll first, we have poll last. Okay, so let's see that as well. It's similar, as you must have guessed. So poll last removes the largest key in the set. Okay, see, all right, it's not clear, so let me add a new line. And now let's see. So first we removed 0, and this was our set content at that time, and then when we did poll last, then the largest key, which was 29, got removed from the set. So these are some of the methods. So there are a few more, like you're free to like go to the TreeSet class and explore all the methods. Okay, so you initialize a TreeSet like this, a HashSet like this, Okay, I'm just doing it one more time for it to be clear. HashSet. Okay, so just remember this. If you're not very familiar with the concept of inheritance and all, I would recommend just remember, like, this is how you initialize a tree set, and this is how you initialize a hash set. Although we can also do like this would also work. Okay, but the thing is, like, some of the methods which are specific to tree set won't work in this case because our type is set. Okay, so to understand this in deep, like, you have to go into the concepts of inheritance, which I don't want to go in this video. So, but you got, so for example, you can just see here, like, poll first is, you can is not accessible now because this set type does not contain poll first method, okay, and poll last. All right, so that is all for sets. So let's talk about Deque. A Deque is a double-ended queue. This means that it supports insertion and deletion from both the ends. So let's try to understand its operations. So let's say I created a Deque, okay, and then I just started with a single value 1. Now what I can do with Deque is, like, I can insert values here also, 2, 3, like in the front also, and also in the back, like 4, 5, 6. So whatever, like, it supports insertion and deletion from both the ends. That's what it means. Now you must have, like, realized that if we want to use this Deque as a stack, how can we do this? We would always add it in the front, and then we would pop it from this side. So this works as a stack. Okay, what if I want to use this Deque as a queue? What I would do is, I have this initial number, and I would always add the new numbers to the end. So 4, 5, 6, and then I would consume it from here. Okay, so that way this Deque becomes a queue. So so as you can see, a Deque can be used both as as a stack as well as a queue. Let's now see some coding examples. So this is how you create a Deque in Java. So I'm creating an integer Deque. So there are two implementations. You can either create a new instance of array Deque, or you could create a new instance of linked list Deque. So linked list especially. So this would also work. What I mean is, linked list, this would also work. Okay, and this would work as a Deque, because Deque is common subtype, a common type to both array Deque and linked list. So that's why we are free to do this. So I would just implement it with one example. So I would use array Deque. Okay, I can also pass in a size, which would be the size of my array Deque in this case, if I want. Okay, but let's remove this for this example. But you know that you can use size if there is a problem that you are trying to solve where you have to restrict the number of elements in the Deque, then you can use this size parameter in the constructor. Okay, so let's see how we can use this Deque as a queue. So if I have to use this Deque as a queue, I have to use these methods: add last, okay, or offer last, and then poll first. So we would add last or offer last. These methods would do is, like, they would add new elements to the end of the Deque. Okay, and then same, like, for it to be a queue, it should, like, consume from the front, right? So poll first or remove first. Okay, these methods are quite clear in their name, so I would suggest, like, use these. Add also does the same thing, but it doesn't mention specifically as whether it's adding to the end or to the front. Okay, add, offer, remove, poll. So I would not use these methods. I would just use, like, add last or offer last. And as we have said before, add last and offer last are same. It's just that add last would throw an exception in case of errors, and then offer last would just return Boolean values. So you can use any of those, but I am going to use offer last here. Okay, so let's see. So I'm going to add few values there. So let's say I'm adding 2. Okay, and then I added, let's say 10 in the end, and this one is 6. Okay, so I added these 3 values, and then let's see our deck content. Okay, so okay, using for each. So for int n in deck n, okay, let's print everything in a line. Okay, and let's see if this works. Okay, so 2, 6 and 10. So we added 3 values, and now if I have to use it as a queue, I have to kind of deck dot, I have to use what these methods, poll first. Okay, we have to remove it from the front, so poll first. Okay. And poll would return like whatever value was polled. So we want to see, it's very similar to what we saw in case of queue and stacks. Okay, so let's see, let me comment this one out. Let's see what poll first returns. So it returned 2 because 2 was the value in the front. Okay, yeah, so if you want to use the deck as a queue, then you can just go ahead and use this offer. You can do it through this offer last and poll first methods. Okay, and all other methods work the same. What I mean is, like, you can again use deck.size to get the size, or deck.isEmpty to get the empty check. So let's quickly see that. Deck.size. Okay, so this would return the size of the deck, which is 3 in our case. So we got 3. Okay, and for empty check is the same. Deck.isEmpty. Okay, so if it's not empty currently, so it would return false. So empty returns Boolean values. Okay, now what if I want to use my deck as a stack? Okay, so here again, so for it to be stack, it is like the last inserted value should be polled, should be removed first. Okay, so what we can do is, like, we can use offer first. Okay, offer first would always add to the first and then remove first. Okay, so, or poll first. Okay, so let's use any of those. So in this case, let me just, or deck simply also provides this push pop peek methods. Okay, but if you're using a deck, I would, like, for the sake of clarity, I think like it's better to use, like, specify the, like, it's good to remember by this, right? Like, if I want to use a deck as a stack, I have to just keep adding the values on the top. So I would always use offer first. Okay, or add first, anything. Okay, so let's change everything. Let's change this to offer first. Okay, and let's change this one as well. Okay. So okay, and let's print it now. So as you can see, 10 is now the value at the front, and if we have to, like, use it as a stack, what we can do is, like, we would do deck dot poll first. Okay, so these two methods, offer first and poll first. Okay, okay, let me do it here. Okay. And then we would also, let's print it, let's print the deck again. Okay, okay, so let's run it and see the output. So 10.6.2 was printed first, and then we don't have a new line, so let me add that and run it again. So as you can see, this was our original deck content, 10.6.2, and then we did a poll first, which removed the top element from the deck, which is 10, and now we just have 6 and 2 on the deck. So in this case, like, deck is behaving as a stack. Okay, and again, size and empty would all work. So there is also a, like, peek method if you want to just see what is at the front of the stack. Okay, so it works similar to what we saw in case of stack. Okay, so let me just write a quick code, deck.peek. Okay, so this would just return the topmost value. Let's remove everything and let's run it. So 10. Okay. We can use any of these methods. So if you want you so as you must have realized, you can use Deque both as a linked list and a stack. So that's about Deque. So that is it for this part of the collections framework in Java. In the next part, which is the last part, we would see a priority queue and sorting and searching, and we would try to write code for some common scenarios which we encounter in our Leetcode questions. So keep watching and thanks.